Hello everyone and a very good morning. Distinguished delegates, presenters and participants from SAARC member states and other regions around the globe. It gives me a great pleasure to extend you all a very warm welcome on behalf of SAARC Energy Center. I am very thankful to you all for joining us in the SAARC webinar on promotion of energy conservation in municipalities of SAARC. My name is Ehsanullah Marwat and I am working at SAARC Energy Center as Research Fellow Energy Efficiency. I shall be moderating today's webinar. Ladies and gentlemen, energy conservation and energy efficiency are important measures to ensure energy security and sustainable development. Energy use in municipal activities is not only one of the largest source of greenhouse gas emissions, it also causes significant burdens on their budget. By increasing energy conservation, municipalities can reduce their cost of energy and emissions. Officials of the municipalities and local government can play an important role to set their targets in this regard. With a view to bringing about energy conservation in municipal sector, SAARC Energy Center has arranged this webinar on promotion of energy conservation in municipalities of SAARC member states. The webinar is structured in a way to suggest solutions and recommendations from experts around the globe for effective implementation of energy conservation in municipalities in South Asia. The webinar will discuss about energy consumption in municipalities and potential areas for energy savings, role of municipalities in energy conservation, sustainable smart cities of future, and solar street lighting and ultra LEDs for buildings. I am extremely grateful to our elite panel of presenters such as Raj Kiran V. Bilolikar, Associate Professor, Energy Area Administrative Staff College of India, Mr. Shah Zulfikar Haider, General Manager of Chittagong Rural Electric Cooperative, Rural Electrification Board, Bangladesh, and Mr. Bruno Lafitte, an international expert, United for Efficiency, UNEP, for their enthusiasm and eager willingness to participate in our webinar. I shall introduce them in detail before the start of their relevant sessions. Dear participants, you will have the opportunity to ask questions to presenters by typing your questions or clicking to raised hand option into the attendees bank of the main window of GoToWebinar software. You may send in your questions at any time during the presentations. We will collect these and address them during the question and answer session at the end of each presentation. Additionally, you will also have a chance to share your views in the knowledge sharing session of the webinar. It is my pleasure to inform you that the Deputy Director SAARC Energy Center, Dr. Shoaib Ahmed, has also joined us in this webinar. We are very thankful to you, sir, for taking out time for your busy schedule to attend this event. I may request Deputy Director SAARC Energy Center to deliver his welcome speech. Over to you, sir.
Thank you, Ehsan. Thank you, Ehsan. My dear friends, participants, and presenters of the webinar. Assalamu alaikum and a very good morning to you all. I, on behalf of SAARC Energy Center Islamabad, welcome you all to this webinar on promotion of energy conservation in municipalities of SAARC. It is a great honor for me to speak to you on this occasion and over an important topic which is expected to play its role in saving important and precious but stressed resource of energy for the SAARC countries. It is needless to repeat that energy is very critical in development and prosperity of the people of the SAARC region. Dear participants, First of all, allow me to briefly speak about SAARC Energy Center and its responsibilities. The inception of SAARC Center as a regional institute and a technical arm of the SAARC Organization on Energy Matters was approved in year 2006. Besides, the center was expected to translate the energy vision of SAARC leadership into reality. Therefore, a governing board equally represented by energy professionals from all 8 SAARC member states was constituted to guide and supervise the center. The day-to-day functional control of the center lies with the SAARC Secretariat. Pakistan, being the host country, shares the major portion of the financial budget. The center started its operations in year 2008. During last 10 years, the center has emerged as a vibrant and effective SAARC institute, which has played its role in all regional level energy initiatives. Until last year, the center has carried out 120 plus interventions. The reports of these interventions are available on center's website free of cost. Moreover, hard prints of these reports can also be asked from the center, which we shall gladly provide. Dear participants, conventional energy resources in South Asia are limited, and all SAARC member states are net importers of the energy products. Ever-growing energy demand in SAARC member states has resulted in their increased dependence on imported energy supplies and has given rise to many related economic, social, and environmental issues. Like other cities of the world, the cities of South Asia account for more than half of the energy usage and generation of resultant carbon emissions. With expansion in urban economic activities in SAARC member states, these figures will further increase. Therefore, it is ensured that urban municipalities of South Asia take a leading role in energy savings and reducing their carbon emissions. Thankfully, there are a wide range of solutions, techniques, and knowledge resources available for improving the energy efficiency in the municipalities and reduction of resultant carbon footprint. However, a quick and integrated approach shall be more desirable. Dear participants, today's webinar is a step in this direction where SAARC Energy Center has put its efforts by sharing the knowledge of the experts of the field with the officials of the municipalities in the SAARC and other stakeholders and interested parties. In this webinar, we have invited experts across the region. I am delighted to acknowledge the great cooperation and support extended by all of them. I extend my special thanks to them. In the end, I once again thank you all for joining this webinar and shall request you to kindly suggest any improvement in the efforts of the center in this regard. Furthermore, I wish you all a very comfortable learning and knowledge sharing in this webinar. May God bless people of South Asia and give us strength to serve them better. Thank you very much and best of luck.
Thank you very much, Dr. Shaib Ahmad, Deputy Director, SAARC Energy Center, for your visionary thoughts and high plans for the region. Well, ladies and gentlemen, let's move to technical session and start with formal presentations. Our first presenter is Mr. Raj Kiran V. Bilolika from Administrative Staff College, India. Mr. Raj Kiran is an Associate Professor in Administrative Staff College of India, ASCI. ASCI provides training to senior civil servants and other top officials of public sector undertakings in India. At energy area of ASCI as Associate Professor, Mr. Raj Kiran leads the energy efficiency and renewable energy projects. Before ASCI, Mr. Raj Kiran worked in Maharashtra State Electricity Distribution Company, one of the largest electricity utilities in India. He has 18 years of experience in leading energy efficiency, renewable energy, and sustainable energy projects in power sector and buildings sector. Mr. Raj Kiran played a key instrumental role in operationalizing mandatory compliance of energy conservation building codes (ECBC) in the state of Telangana and the state of Andhra Pradesh. Currently, he is working on strengthening the implementation of energy efficiency code compliance. He holds an MBA in Power Sector Management from National Power Training Institute, India, and Bachelor of Engineering from Government Engineering College, Aurangabad, Maharashtra. I may request Mr. Raj Kiran to give us an overview of energy consumption in municipalities and potential areas for energy savings. Mr. Raj Kiran.
Thank you, Mr. Ihsanullah. I must thank Mr. Ahmad Sheikh of Deputy Director of SAARC Energy Center. And very good morning from Administrative Staff College of India to all the attendees who are listening to these presentations. And I must thank the SAARC Energy Center Islamabad for giving me an opportunity to share my views on energy consumption potential in municipalities. Though I am going to talk on other potentials, but I will cover mostly on energy conservation building code implementation, which we have, which we are working from last almost 8 to 9 years, and that is one of the success story which I wanted to share it with all of you. Can I share the presentation now, means Mr. Ihsanullah? Hello.
Yes, Mr. Raj Kiran, we can hear you. Please carry on. Because
Yeah.
all other participants will be in silent mode. That's why you please carry on.
Okay. It's means the presentation. Are you sharing it, or shall I share the screen?
Be sharing your own screen, sir.
Give me
Because
one
you have
second.
the right. Yeah, please.
I am just opening the presentation.
Yeah. And please share your screen.
Yeah, I do.
Yes.
Yes.
Give me one second. So thank you very much. I hope everyone is everyone could see the screen and presentation. I will start with energy conservation in municipalities and potential for energy areas for energy savings. As
Yes.
Mr. Ahmed mentioned,
The screen.
excuse me.
Well, we can see your screen, so please go ahead.
Yeah. So thank you very much. Uh, as Dr. Ahmad Sheikh mentioned, that electricity demand is really growing, and we are really concerned about the climate change, carbon dioxide emission reduction, and as well as the growing energy demand, which is pretty high in this region. And that's how means the World Energy Outlook uh, actually expecting that China is really growing like anything, and 9,000 trillion watt hours, and India is one of the major contributor, and Southeast Asia is also one of the major contributor in electricity demand raise, because mostly the economic activities, the industrialization, and the buildings, municipalities where the large appliances are penetrating, though it is lighting, heating, ventilation, and air conditioning, and pumping, that those particular kind of things are coming up rapidly, and this increase in demand is happening, and hence it is a serious concern for the municipalities to go for either renewable energy or energy efficiency in the systems. As we can see, where the new policy scenario suggests that 44% we can actually save the carbon dioxide emission by bringing up the energy efficiency portion in these all sectors. 36% contribution can come from renewables, and then slowly we can shift towards these particular kind of things. And the sustainable development scenario also suggests these kind of carbon dioxide emission reduction by 2090 by 2100, where all efforts, all policies, say it is industry, say it is electricity distribution or power or municipalities, they must have to go towards this. With this, if we think about Indian condition, the energy saving potential in India is pretty high. Only power sector, if we can actually bring the electricity consumption and bring the energy efficiency in the power sector, by 2031 projections say that 109 million ton of oil equivalent can be saved. And in building sector, residential, lighting, commercial building sector, shops and malls, offices, hotels, and space by space conditioning at home, 4.6 million ton of oil equivalent, hotels 2.6 million ton of oil equivalent, offices 2.8, residential 10.1, lighting 5.1. So there are several, it's a huge potential where we can actually go for and then save this energy in a very effective and big way. So the reason for energy efficiency in municipalities in India, average 4% of total electricity consumption comes from municipal sector. And municipalities are spending large amount of their revenues on purchasing electricity energy for providing local public services like street lighting, water treatment, water supply, sewage pumping, buildings and electrical distribution. 25% of savings can be done through these cost-effective actions if we actually move and implement very efficient practices in all these sectors. Through energy efficiency, more than 100 gigawatt additional coal capacity can be avoided until 2047. That is like Indian projections. If we further drill down and where this electricity consumption actually is there in municipalities, public lighting, water works, public lighting somewhere around 1%, water works is a major contribution 3%, commercial buildings it's almost 8%, domestic buildings means residential buildings 26%, irrigation is the 22% and the industry 36%. So out of this 4% is municipal energy consumption. So we can actually major areas where this load is coming and where the essential area of energy efficiency we can actually focus on: street lighting, water pumping, sewage pumping, electrical distribution and municipal buildings. India went ahead and then actually if we see the reasons for energy efficiency projects in municipalities, India is plagued by high operating expenses in the supply of water. Anywhere between 40 to 60% of energy costs arise only from supplying water. And if we implement energy efficiency measures in the pumping systems, 4,800 million units in electricity is wasted every year due to inefficient water pumps, which we can actually save by effective implementation of these energy efficiency measures. Coming to the building sector, according to the McKinsey Global Report in 2010, 66% of the building stock by 2030 yet to be constructed. In 9 years, we achieved a lot of potential, lot of area, and then we constructed so many buildings. So built up area is coming up with most inefficient practices. Like the glass buildings, mostly people are using glasses. They are not applying the insulation properly, and because of this glass, buildings are becoming ovens, because mostly India is in a hot and dry climate zone, except a few areas, northern areas, but most of the country comes in this particular kind of dry and composite zone or hot zone. and where we are constructing these particular kind of buildings with glass, where solar heat gain coefficient is also more, means glass is inefficient glass, so it gives visual light transmission as well as the solar heat gain, and becoming all these constructing these buildings as an oven. To cool these buildings, we are putting more and more HVAC component, heating, ventilation, and air conditioning component, and then thus the demand is increasing. This is a very critical area where we need to address, and we have addressed with energy conservation building code implementation. Street lighting, which is a very critical area for every municipality as energy bill is concerned, and then this is really increasing because the cities are growing, urban population is growing. Every 4 years, according to IEA, Shanghai size of city is adding in this urban population. So that's how the cities where the new development is happening, street lighting becomes very important and critical component where we can actually think and change and bring efficient LED lighting system. And India has taken up very big, large program. I think other panelists were also talking about that, and I will cover in next few slides about how India went ahead with the solar LED street lighting system. So with this energy targets of India, we are planning to target 20 to 40%, approximately 4,800 million units of energy savings per annum, avoid the need for an additional capacity of more than 3,300 megawatt, reduction of 3.9 million tons of carbon dioxide emissions per annum, and monetary savings of approximately rupees 3,200 crores per annum with all these energy efficiency projects we are planning. How we address this? We have standards and labeling program with appliances. So many of the appliances, right from now the washing machine recently included, air conditioning units, fans, tube lights, motors, pumps, every appliance, refrigerators, they come with standards and labeling so that the consumers can understand what kind of energy that particular equipment consumes and what kind of percentage energy saving can happen with that. And with that they have the 1 star, 2 star, 3 star, 4 star, 5 star systems so that consumer can make a decision to save energy at their end. Energy conservation building code, which came in 2008 to address the energy conservation in a larger construct, a larger context at the design stage of the building itself. Agriculture DSM, it's a demand side management program where pumping and water pumping efficiency brought in the water pumping system. Municipal DSM basically talks about the street lighting as well as the water pumping and sewage pumping. But with all these things, they developed the capacity building of discoms. At ASCII, we trained more than 1,000 people in last 4 to 5 years on municipal DSM programs and energy conservation building code. Ujala is one of the scheme where government of India is distributing LED lights uh, in municipalities as well as in buildings, residential buildings and all. Strengthening of state designated agency, how it happens, because India has a large program and then we have Ministry of Power and Ministry of New and Renewable Energy looks after this kind of program implementation. Ministry of New and Renewable Energy mostly they implement renewable energy projects, whereas Ministry of Power implements these power related and energy efficiency projects. India has Energy Conservation Act 2001. I think all the attendees know this. And Bureau of Energy Efficiency is the nodal agency to implement Energy Conservation Act across the country. But every state has one designated agency, and this designated agency coordinates with the central agency of Bureau of Energy Efficiency and implement all these programs. Say it is municipal DSM, municipal energy efficiency, street lighting program, or energy conservation building code program. It coordinates with the center and state, and then it implements. I think this few state designated agencies are really active, and then they are implementing in a very effective way, and few state designated agencies are not that active, so strengthening state designated agency becomes very important in implementation of all these programs. Obviously, the contribution to State Energy Conservation Fund, Perform, Achieve and Trade and Super Efficient Equipment Program, Domestic Efficient Lighting Program, Energy Efficient Financing Platform, and all other programs are there in India to support and strengthen the energy efficiency implementation. The municipality demand side management scheme of Bureau of Energy Efficiency was initiated in 11th plan. The objective of the project was to improve the overall energy efficiency of the urban local bodies, which could lead to substantial savings. But how? They issued the energy efficient street lighting guidelines, and they brought the energy efficiency scale-up program with Ujala and LED street lights, deployment of efficient ceiling fans and LED tube lights, along with successful LED bulbs procurement and distribution. So the problem here is, means the municipalities, they can take up all these kind of programs, but then in India, and I think it's our countries also, most of the urban local bodies are cash crunch. They have the serious cash problem. So they won't actually able to procure the a super efficient energy equipment. Hence, India brought up the energy service company concept, and India established one energy service company is Energy Efficiency Service Limited, which acts as energy financing company to the municipalities. They sign the agreement, and Energy Efficiency Service Limited is distributing and helping municipalities and urban local bodies to procure these energy efficient equipments and deploy in the municipalities. So though it is lighting purpose, though it is street ceiling HVAC heating, ventilation and air conditioning purpose or pumping purpose, ESL is signing an agreement with urban local bodies, and then they are taking care of this implementation. The percentage saving after defining the baseline, whatever the percentage saving is there, that percentage saving municipalities and urban local bodies share with the Energy Efficiency Service Limited, and they accordingly they sign their financial agreements. So under this street lighting national program, ESL has installed over 50 million LED street lights in 3 years across more than 500 municipalities. ESL enters into long-term annuity agreement with municipalities to retrofit existing street lights and LED pump lamps and fixtures. The entire investment is made upfront by Energy Efficiency Service Limited, and as I mentioned, that it is recovered from energy savings of municipalities and cities. So here LED lighting brings a better quality of lighting together with over 60%. We are expecting average annual cost savings, because it is very interesting phenomenon which happened in Indian municipality sector, where we used to have 40 watt and more tube lights are replaced with 10 watt LED bulbs, and then HPS, high pressure sodium lamps, high pressure mercury lamps are now being replaced with the LED, where lot of potential energy saving is now been actually seen in many municipalities areas, and they have reduced their energy bills tremendously. Where I Administrative Staff College of India is situated in Hyderabad, and Greater Hyderabad Municipal Corporation has a very efficient program of LED lights, changing the street lights to the LED, and they are saving more than 4 to 5 crores every month because of this switching to the LED street lighting program. Uh, and that's how it is actually not only reducing the energy consumption in the street lighting, but then it is improving the financial strength of the urban local body, where they can actually put certain kind of efforts in other areas which is required in SAARC countries and in India. So coming to, and it is not only because now as we are talking about energy consumption and potential areas, so when we talk about street lights, it is not just an energy inefficient equipment and all. It has to be designed in a very integrated approach way. So only LED street lights won't serve the purpose here. Selection of energy inefficient equipment, poor designing practice of street lights, because now when you are switching to high LED street lights from high pressure sodium vapor lamps or mercury lamps, your entire pole size and the fixture size must be designed in a very different way, and those particular kind of parameters must be specified in your RFP and specifications. And that's how you design a very efficient street lighting system rather than inefficient street lighting system. First, we have observed our experience is few municipalities and urban local bodies just went ahead and then replaced the existing HP, whatever street lighting system, conventional street lighting system with just LED system. It gives very bad results because the lux level, the angle of that particular LED fixture that won't come into the onto the road, and lux level at the road measured after that was very less. So it is not just switching to the LED system, but it is to design the overall system with pole height, with LED and light angle, fixture angle, and then the real benefits can be measured. So following parameters really contribute, like improper pole-to-pole spacing, angle of title, inadequate or higher mounting height, interruptions due to roadside trees, improper selection of lamps and fittings, poor maintenance. So now we have one very good example of Baroda city lighting and non-lighting design-based lighting system, where 300% improvement in service delivery, because only lighting and switching energy conservation is one aspect, but in service delivery is another aspect in municipalities that has to be always thought. And when we integrate with energy efficiency with service delivery, that gives tremendously very good results. So 300% improvement in service delivery happened, and 58% energy savings were observed in Baroda city, where if you can see the lighting system, the earlier lights, street lights, the darkness in between the two poles, it is being clearly observed. Now the street is very well lit, and the light is there, and even extra light pollution is not there. Uh, so these kind of achievements actually we can have with energy efficient systems. So average illumination was 30 to 35 lux with 40% uniformity, and with 58% of saving they have achieved. 33% of saving they have achieved. With this particular LED street lighting and energy saving under SLNP program, Uttar Pradesh total LED street lights installed and almost more than 30.02 million units were saved with large savings, and 50 lakh street lights in over 500 cities in India, leading to 135 crore units and 742 crore rupees every year they are saving. It is aiming to replace all 1.34 conventional street lights with 15 lakh tons of carbon dioxide emission reduction, and 190 road units can be saved with this program. So that is the really big target and challenge, but then people are accepting because it is giving them service delivery benefit, lighting benefit, as well as the financial benefits and strengthening the ULBs. So ULBs are coming forward, and Energy Efficiency Service Limited is actually working with ULBs in a very effective way. Coming to the water and sewage pumping system, there is 2.57% relative to total energy consumption by all sectors. More than 20,000 million unit saving potential is there in this. Effective ways we can actually have the proper maintenance, monitoring, controls, reduction of demand, more efficient pumps can be done, proper pump sizing, multiple pumps for varying loads. Because in what we observed in our day-to-day working here in India, most of the pumps are old pumps, and whenever you actually repair or maintain these pumps, certain kind of inefficiency adds into that. So the pump repairing also affects the entire operation of pumping, and it brings lot of energy efficiency into the inefficiency into the system. So replacing pumps with the super efficient pumps, more efficient pumps, and then maintaining them properly, and the skills of the maintenance people need to be developed in such a way so that the efficient, whenever the maintenance and repair happens, the inefficiency must not come. So it is not just the replacing pumping system, it is overall kind of system, integrated system, where we need to think about, and then real energy efficiency on a sustainable way can be achieved in the pumping and sewage treatment system. Coming to the building sector, as I mentioned, by 2030, almost that 66% of the building stock yet to be constructed. So India went ahead with energy conservation building code to construct the buildings according to certain kind of code, and where we can actually save energy at the design stage itself. 1930 million meter square current is there, and then yet to be built 66% of that. So it was a great opportunity to go into this building sector and then see where we can actually convince government buildings as well as the real estate developers community to save energy at design stage itself. So energy conservation building code brought by Bureau of Energy Efficiency in 2007 and 2008, which actually talks about minimum energy efficiency standards for design and construction of commercial buildings. It is only for commercial buildings because the Energy Conservation Act says that Energy Conservation Building Code must be applicable to all commercial buildings on a mandatory basis. Recently, in 2007, Bureau of Energy Efficiency modified the Energy Conservation Building Code, and now it is Energy Conservation Building Code 2017. But when we started, it encourages energy efficient design of new buildings and major renovations. Means it's both the retrofit as well as the new buildings. It addresses local design conditions because India has several, as I mentioned, mostly it actually comes in the dry and composite, but then if you go to the local climatic conditions, India is divided into 7 kind of zones. So composite zone, a dry and hot zone, and if you go towards north, cold zone. So buildings must be constructed according to those climate zones. This particular code talks about the local design conditions and helps improving existing construction practices, and emphasis on it emphasizes on integrated building design approach, because when you construct the building you have to integrate your construction practices, material procurement, sourcing the material, as well as your designs, HVAC designs, and the use of that building. So when you are ready with all these kind of things and integrate at the design stage, that particular kind of design will give you more efficiency rather than just prescriptive approach. And ECBC emphasize on integrated building design approach. It is like it talks about building envelope. It talks about heating, ventilation, and air conditioning system. It talks about lighting system. It talks about electric power, as I mentioned, the pumps and everything, and solar water and pumping system. It gives you prescriptive approach, compliance approach, and whole building performance approach. Prescriptive approach means it is just like the envelope. If I take an example of envelope, it gives you the code. It gives you certain kind of specifications that glass must have this particular kind of solar heat gain coefficient or visual light transmission. Over and above, it won't allow. Roof resistance, it must be this much of roof resistance. Window to wall ratio, it says that okay, this much of window to wall ratio is allowed, more than that it is not allowed. So these kind of specifications, if you actually follow, that is called prescriptive approach. But then there are many simulation techniques which are available, where you can combine all those parameters, specify and design your building accordingly. That is called whole building performance approach, which is more flexible, and you can actually trade off that whether you are not using, because you may not, because 5-star hotels may like to put more lights in their lobby, and designer lights in their lobby, lighting systems in their lobby, which are sometimes inefficient lighting system. But then they can actually trade off with certain kind of things in the wall insulation and roof insulation and glass usage. So whole building performance gives you flexibility, whereas the prescriptive performance, prescriptive compliance approach won't give you that kind of flexibility. So these are the approaches. But when we started, now coming to the municipalities, this is very interesting, because energy, mostly the energy deals with the energy department, and municipalities deals with the building department. So how can you make it mandatory, and how you can enforce it? So we designed this model here in Telangana and Andhra Pradesh that real estate developer first consults with mechanical, electrical and plumbing consultant or the energy consultant and prepares the designs. They submits the third party assessors because our GHMC means our urban local body officials. They said that they are not experts to understand energy conservation building code in an effective way because it talks about the envelope architectural concepts as well as the HVAC concepts, electrical concepts and other concepts. So how to implement this? So we suggested that there must be third party assessor. These third party assessors are trained people who understands the energy conservation building code and they issues the certificate. Now how to make it mandatory? So when building comes to any urban local body or municipality for construction approval, in that construction approval, if they submit a certificate that this particular kind of design is according to the energy conservation building code design, then and then only construction permission will be given. Now in Telangana and in Andhra Pradesh, they went ahead with the online building construction approval system, which is very easy for under ease of governance system, and ECBC certificate they made it mandatory. So if you won't upload the energy conservation building code certificate given by third party assessor, your application will not be accepted by the system. Now here in most of the SAARC countries, but then in India especially, there are certain kind of transparency issues earlier. Now with online approval systems and all, these transparency issues are coming down, but then people submit the designs separately and then the construction is not according to the designs in most of the time. So how to actually address this issue? So we said that before occupancy certificate, after post construction, one more check will be there and third party assessor will check that whether that particular building is constructed according to the submitted designs, then and then only that particular kind of occupancy certificate will be issued, otherwise it will be rejected. So this system, real estate developers earlier they opposed because there is a split incentive problem. Because if I construct the building and then there uh, I may incur more cost and then I may have to sell it on more cost. So initially they didn't agree for this particular system and they said that we are not going to be part of this. But after a lot of stakeholder consultation at urban local body and municipalities, real estate developers agreed for this and they went ahead with this system. Now I am glad to share with you that Hyderabad as is the first city to implement energy conservation building code on a mandatory basis, and we have more than 120 buildings approved with energy conservation building code compliance certificate. So I can show you few third party licensee format. So this is the third party assessor licensee format. It enables GHMC to monitor the third party assessors. These people are trained people and they check the designs and then they issue the certificate as to the real estate developers that their buildings are energy conservation building code compliant. Now this is an innovative system which we brought in addressing and motivating and promoting energy conservation in buildings. This is a STAR system which is now government approved STAR system at design stage as well as the occupancy stage. So green color is occupancy and yellow color is design stage. So design stage, the building itself says that it displays the general information and technical information. If you see the right last row and then right column, project base case EPI and then existing EPI is ratio and percentage of savings is 12%. So builders, real estate developers and buildings can actually promote that this particular building, government approved building is saving 12%. It it has then automatically it is a market instrument for them and then people are now coming forward to get these certificates for buildings. So that is very successful case here in Telangana and at occupancy stage also we issue these certificates and then we check that 10% savings according to the design stage or not. And I can tell you here that IKEA building, which is now first IKEA store in India, which is in Hyderabad, got first occupancy stage certificate also in Hyderabad. So it is now full-fledged system, and we are trying to improve this system with certain kind of energy passport systems, where buildings can showcase in next 3 years post construction that we are saving energy according to the energy savings which we have submitted to urban local body at design stage as well as at occupancy stage. So based on that, their market value, lease value, rental value and sale value also can be linked in future. And that's how real estate developers as well as customers, they are coming forward to adopt this system in a very effective way and efficient way. The municipalities, this is the Greater Hyderabad Municipal Corporation website, where they actually put all kind of information on energy conservation building code and energy. So urban local bodies are now coming forward for these particular kind of new innovative systems in of energy conservation, where they need not to incur money, they have to support the system. Government has already said that we are not going to give here the property tax incentives or another other incentive systems, because energy conservation in buildings itself gives certain kind of benefits to the consumers as well as the people who are staying in that building or using that building. And that's how it is like the burden on urban local body is less, but then energy potential, saving potential is pretty high with these particular kind of innovative mechanisms. And ease of governance and market instruments for sale of these particular kind of properties are actually attracting the real estate developers as well as the consumers. So as I mentioned, with all these things, there are environmental benefits, economic benefits, utility system benefits, and risk management can happen. Uh, we have an opportunity, the energy costs, investing in energy efficiency. Local governments can achieve substantial energy cost savings across their facilities, improving the efficiency of existing and new facilities. Local governments can incorporate energy efficiency criteria into product procurement decision. Water and wastewater facilities, where they can actually put these kind of energy efficiency systems. Government buildings, these are very important places where we can actually demonstrate. And now the government declared that in Telangana and even in Maharashtra, one of the state in India, 1,000 buildings, uh, old buildings, they are going for retrofit to save more and more energy. So not only new buildings, but then old buildings also people are coming forward for retrofit, and then those will be the demonstration projects where other people can actually come forward to put this. And one more program, in fact, I didn't share in the presentation, but I want to share it with you. Recently, we have launched the Cool Roofs program, because the emissivity of white roofs on top, which is very prevalent practice, ancient practice in northern India and western India, with mosaic tiles on roof, that actually reflects the heat. And with new construction practices, somehow we are not constructing our roofs according to these cool roof practices. Now we are encouraging in all municipalities. This is one case where it is disaster management for heat waves and reducing the urban heat island effect also, as well as save energy, because it we have experimented in one of few of the slums in Hyderabad, and that gave very good results, that 2 to 3 degrees centigrade reduction in ambient temperature inside house, which also reduces your fan load as well as your HVAC load. So these are new practices which are actually we are promoting in all municipalities, and a lot of massive awareness campaigns. And in coming summer, urban local bodies in the state of Telangana and AP, they are actually moving forward with this to attract people and then convince people to go for cool roofs. So residential buildings also, it is a huge load, where energy conservation building code is applicable to commercial buildings, but Bureau of Energy Efficiency brought up residential building code also, we, as of now, we are not making it mandatory, but then uh, we are implementing residential building codes also. So with this, I think these are the steps for developing municipal energy efficiency projects. Other panelists are also going to talk on this, so everyone knows about this. So with this, I'll stop here. Thank you very much for giving me an opportunity to talk on this topic. If you have any questions, I request you to please post it so that I can answer. Thank you very much. I thank SAARC Energy Center and even Mr. Ihsanullah for giving me an opportunity. Over to you, Mr.
Thank you very much, Raj Kiran. Thank you very much. It was indeed a very informative and detailed discussion on the overall scenario of energy situation in the municipal sector. We will have certain questions for you. One of our colleagues from Bangladesh's question is somehow sort of interesting, but obviously we want to know that how some experienced municipalities have overcome this issue, because it's very common, and particularly in South Asian culture, it is a common thing that he's interested to know that how these batteries for this, so if in case we go for solar lighting in street lighting, I mean solar panel based lighting. So for that he is interested that how usually these experienced people have secured their batteries, and another problem is that how tactfully the cleaning of the solar panel has been addressed.
Yeah, coming to the battery, earlier they used to have the lithium ion batteries, lead acid batteries, and those were the real problem because the maintenance and everything was a real problem, and then even exchange of those batteries was a problem. Now these new solar panels are coming up with lithium ion batteries, but the ESL program which I mentioned, those are not solar street lighting program. Those are LED program. So LED, where actually it brings down your energy consumption in a very big way and drastic way. But coming to the battery size, now lithium ion batteries, earlier there were so many problems in implementation of these solar panel as well as the battery. So the issues were like maintenance as well as the theft of lead acid battery. Now these lithium ion batteries, which are very small, and these are maintenance free batteries, and these batteries are they are actually coming up with the durability of 6 to 7 years, and the manufacturing of this particular kind of pole with the solar street light, earlier those batteries used to have, they used to put it on the mid pole, but now the fitting is coming, this lithium ion battery is actually fitted with the solar panel only. So that's what the cost has been reduced. The battery replacement has been drastically reduced, but still it has some issues. And people are going forward with solar street light. But then India has actually went ahead with the proper conventional electricity, but with LED street lighting system. So LED street lighting system reduce load drastically in the street lighting sector. Hello, over to you.
Yeah, thank you very much, Raj Kiran. You have explained very well, because it was also I was also interested in the same issue. Well, there is another question from Afghanistan that they are asking, since you mentioned about the efficient poles, I mean the street poles which you have mentioned different from the conventional poles which you are using for the LED lighting. So how they are efficiently, I mean different in terms of efficiency?
What happens, basically what I was mentioning, that conventional pole height and it's sometimes in street lights it's like 6 to 7 meters. Yeah, correct me if I'm wrong, Professor Ihsanullah ji. But these particular kind of pole height with conventional lighting system, which is mostly HPSV or high pressurized mercury lamp and other lamps, even tube lights, those pole height compared to our LED light, because LED actually gives you the angle of that particular light, it directly comes on road, so it is the angle of that particular light in LED is straight, whereas the HPSV and HM vapor lamp and other tube light, it is a diffused light. So it actually diffuses in 35-degree angle and other angles, whereas LED actually gives you the straight angle. So based on that particular kind of aspect, your pole height must be designed. It has to be reduced to certain extent, and then the fixture problem is also there. LED fixtures are different than your conventional tube light fixtures and HMSV fixtures. So entire pole need to be designed to suit LED lighting system. So you cannot just like change the fixture at the top and then put the LED there. If you do that, then the proper lux level on the road, mid of the road and then side of the road, you will not receive that in an efficient way. So you have to change the pole design with the fixture design, and then you will get the proper efficient lighting on the road.
Thank you very much. Agreed with your comment, and also it might be the weight of the LED light, which will also impact the structure of the making of the pole. One last question, because sir, please carry on.
No, I was just saying that there are other parameters also. There are so many parameters. I mentioned just 2 or 3 parameters which are like important parameters, but there are other technical parameters also. Yeah.
Sir, we will take one last question because we are already short of time and we have covered our time. One colleague from my own office, Mr. Bilal Hussain, who is interested to know that how much lighting contributes to Indian peak electricity demand.
I didn't get this. Pardon me.
Actually, he's interested to know that how this lighting contributes to peak electricity demand in India.
It actually contributes percentage wise. I don't remember, but then I think I mentioned in my few of the slides, like somewhere around 2 to 3%, particularly from lighting only it comes, because in peak actually mostly in the evening period to evening peak, where nowadays peaks are also changing in India due to other reasons of HVAC component, but the lighting actually affects very highly in the peak, but then somewhere around 2 to 4%. I don't have right figures, but then I come back to you and then I can send you the email accordingly.
Thank you so much. Thank you so much, sir. Thank you for giving us your precious time.
Yeah.
Thanks again from all of our colleagues and our participants. Thank you very much. So, ladies and gentlemen, our next presenter is Mr. Shah Zulfikar Haider. Mr. Shah Zulfikar Haider is a professional engineer and certified energy auditor from USA. He has 35 years of experience in energy, climate change, and military engineering services. He is an international level. He has international level expertise in sustainable energy, renewable energy, energy efficiency, and management of electric utilities. He has attended several international conferences as speaker on future energy, digital disruption of utilities, smart grid, energy efficiency in different nations like USA, Belgium, Singapore. He has many international publications on energy, total quality management, and sustainable energy. He also has received National Award of Best Officer in Energy Sector during National Electricity Week 2010 from Government of Bangladesh. He was the first director of Sustainable and Renewable Energy Development Authority, SREDA, Bangladesh. He worked as a member of Committee to Solve Power Crisis of Bangladesh and is working as member of Task Force for Technical Employment Generation in Bangladesh. At present, he is General Manager of Chittagong Rural Electric Cooperative under Bangladesh Rural Electrification Board, BREP. So I may request Mr. Shah Zulfikar Haider to share about the sustainable smart cities of future.
Can you hear me?
Yes, sir, we hear you, but there is a lot of noise in background. Maybe it is a fan or something like that.
Background noise.
Yeah, there is a huge background noise.
Hello, can you hear me now?
Yes, it's much better now. Thank you. Please go ahead. Your screen is also visible. Please go ahead.
Assalamu alaikum. Thank you very much. I really enjoyed Mr. Raj Kiran's excellent presentation. It was very informative. Thanks a lot to SAARC Energy Center and all my colleagues there, because it's a noble thing you're doing for SAARC and for other also, that free information exchange and technology exchange is a big thing. Most of the time we find that we have to pay for that. So thank you, sir. Assalamu alaikum. Good afternoon. Namaste to all my dear friends. Today we find everything smart. There was a time when we used to think that smart means a person is smart, but now when you talk about your technology, your home, you think about smart home, you think about smart environment. Even when it comes to casual dressing, you find that it's written that you come in smart casual. And smart technology is very much related with ICT. So I am an infrastructure specialist, and today I've got two co-authors. One is Sada Faider, she is an ICT expert from Malaysia, and Fahad Haider is a researcher and he's renewable energy and energy efficiency expert. He's in Australia. Together with the team, we have prepared this paper. Now, smart has got many definitions, but in general, people say that specific, measurable, achievable, realistic, and time related. But I've got a very simple definition: is efficient to highest level. And efficiency to highest level, it has got no boundary because technology is changing, your demand is changing, everything is changing. Even you will find that in sustainable SDG, which is formulated, the number one is sustainable cities and communities. But these sustainable cities are again should be smart cities. Now, what is smart city? A city or a municipality, it is integration of the people who are living there and the facilities which they generate and they expect from the government. For this thing, we need to have three layers of technology. One is that the primary layer, we often hear the word big data, that data are generated. And the next layer is that the data are transmitted. And the third layer, you have the software through which a data is analyzed and transmitted in different forms, like through the help of sensors or other things. Like it can be used to track your aircraft, or you track your bus timing, etc., etc. So all these things, what you find is that, as I mentioned earlier, that it depends on the people who are staying there. So for that, the people who are staying there, first of all, we'll talk about their demand, that people have to be educated and that they have to understand, they should be motivated that we have got some contribution to our society. The government, they has also got a contribution. They have to be very accessible. They have to take the things very easily. Like in Bangladesh, we have got one good thing that we have called it access to information. All people, they can have access to everything of every organization, every government organization. There's nothing secret in it unless and until it is secret for national security. But people need to have access. If one applies for electrical connection, He can be able to track his application procedure, and if it is delayed, he should know why it is being delayed. The environment where we are staying, that has to be sustainable, and that has to be acceptable to the demand of the people. All these things are going to change the quality of life. But the quality of life changing, everything this depend on money. For that, you need to have already a smart or sustainable economy also. That is, everywhere the losses should be less and your productivity should be more. Society as a whole, it should be integrated, and they should be based on this, that we had a proverb that time is money. That is the basic thing of smartness, that less time is wasted. Similarly, as I said earlier, that less time is wasted. The mobility is a big concern in many urban places because people are moving like anything to urban places for employment generation or other reasons. And mobility has to be there. Most of the time is lost in roads, traffic jams. A smart technology, smart city has to solve this thing. Now, there are two things: smart city and smart municipality. But the basic thing which I said earlier, that it has to deal with what public want. Basic first requirement is water supply. You need to have efficient water supply. You need to have less water is wasted. Like it is a very common in SAARC and developing countries. Our water supply is not sensor controlled. And so we have a lot of wastage of water. And everything, whether it is water supply, it is any technology, it is, you need electricity for that. And electricity is such a thing that it is, demand varies from time to time. So you need to have very efficient electricity system so that your demand is met, again, it's not wasted. In most of the countries, electricity is subsidized or public utility service is subsidized. The more is the loss, is not subsidy to the government, it is subsidy which is borne by the people. So then solid waste management, it is another issue. It has to be catered. And if in SAARC countries, in many countries, it is found that if solid waste management could be done, then we could have easily generated electricity, but waste collection is a problem. Sanitation sewage is another issue. And it's a big issue because with the urbanization, you need to cater roads, sanitation, sewage. You have to plan ahead what is going to be your condition after 50 years or 40 years. Because with very rapid urbanization, this calculation of many engineers have failed. I will not use the word fail, but I will say that you have to go for more and more, and it's very difficult to change sewerage and sanitation system. And another issue is that globally our economy is increasing. So we are going towards more luxury and we are going towards more transportation. As a result, we find that our transport system has been deadlocked, especially during office hours, and when you come back, you have to wait for hours on the roads. You have to go for smart technology to solve it. I will give an example of Japan. They are the most producer of the cars, but a Japanese car in Japan is more costly. You have to pay more tax because of the fact that if all people, their roads have a limitation, if everybody drives car, then a lot of time will be wasted there. So what have they have developed a very smart alternate transportation service system. And the record is that it is not even late by minute. So overall, the thing is that minimal time wasting is the main criteria for smart technology, smart city, smart municipality, whatever you say. I've got a video here, you can hear it. Now, the basic element of smart city, you need to have a very high speed, reliable internet connectivity.
Dear Mr. Shah, we are unable to hear you. Dear participants, please bear with us. We are having some technical issue with Mr. Shah Haider. He will be joining us back soon. Maybe some technical reason. Meanwhile, I may request you that you will have the opportunity to ask questions to presenters by typing your questions or clicking to the raised hand option
It
into
has
the
to be.
attendees. Yes, welcome, Mr. Shahid. Please carry on. Hello. Well, ladies and gentlemen, still we are having some connectivity problem with Mr. Shah Haider Zulfikar. As I requested you earlier that we will have the opportunity to ask questions and to presenters by typing your questions or clicking to the raise hand option in the attendee span of the main window of GoToWebinar software. You may send in your question at any time during the presentations. We will collect these and address them during the question and answer session at the end of each presentation. Additionally, you will also have a chance to share your views in the knowledge sharing session of the webinar.
Can I proceed now?
Yes, sir. Welcome. You can. We all are waiting for you.
Oh no, there's some noise. Something was instruction was coming about. Yeah. Yes. Okay. Now we need to have smart power management. This is the main challenge of today's people managing electricity. For that, we have got smart grid. You have got smart meters installed. The best thing is that it controls, it monitors your consumption, and in case of crisis of electricity, it can even control the electricity use of big industries, or say for example, for residents, it can control or tell you that you minimize your AC to this level, or it can even automatically control. That is, your infrastructure and everything is having runs at optimum level, and it not only that consumer saves electricity, but the system as a whole is healthy. All these things are based on sensors. So we all know about sensors, that you have got everything. If it's starting from pacemaker, everything you have got sensor, but sensors, it is going to be a multi-billion-dollar business in coming days. It's already having, but it's got many concerns. Hackers are disturbing now and then. A couple of years ago, an amateur hacker, he sent a malware to a remote water utility in America, unknown utility, very small utility, and the entire system was damaged. Now today, from aircraft to industry, every industry you are having sensors. You have to based on sensor. And they were in America, there were false alarm of sensors, and their bombers with atomic weapons, they flew. So this is a concern, that the more you have to be smart, the more you have to be careful about if you have to place barrier, and your cyber security concern has to be well addressed. National cyber security concern is very well addressed by the government, but say individual, for banks, for business, you have to develop your own system. Smart technology, smart grid, smart cities, everything is nice, but it affects your privacy also. So there are many people, especially the old people, they often say, oh, we don't want this smart gadget, smart, we don't want smart TV and other things because everything is monitored. Hackers are so smart that even they can have control of a smart TV, and from the camera of the smart TV, they can take the video of the surrounding and they can even harm you. But you cannot stop it. World cannot stop. You have to be with the technology. We have to be with the smart technologies which you are having. There are always means for that. For example, with a smart TV, just put a dark colored piece of paper on your camera when you don't need it, and that this way you are safe. You need to be smart to what level? In SAARC countries, India has really coming up. They have taken up a target of more than 100 cities to be developed a smart city. China is doing excellent. I will say that they have got smart shopping mall. I will show a small video. In shopping mall, the main hassle is payment. You buy a lot of things you buy, and then you find a big queue. So they have developed that the moment you enter the shopping mall, you just punch your credit card and it is taken, and you buy everything and you come out. And it is so scientific that it is also theft proof also. So your time is saved, and again, the time of the store management is also saved. They have gone out to such a level that through your retina scanner, the moment you enter the shopping mall, you even don't need not to punch your card. You buy the things and you come out, and you in your smartphone you will find that whatever you have purchased, it has been debited. I would just like to show a part of a video on it. I have just shown the part of the video that the other part will show that if anybody tries to conceal his identity, the face, then he cannot come out. All these smart things, they are based on IoT, or even you have got that IoT is based for smart city infrastructure, and because whether it is a digital traffic signal or whether it is a marketing or whatever you do, you need to have Internet of Things. Then again, you have got Internet of Energy, and now you have got Internet of Everything. Especially where after the full development and implementation of 5G, you will find Internet of Everything there. For your smart city, smart environment and everywhere, whether it's a phone call, whether it is medical. For example, I will say that previously we used to have smart meters for only electricity, but you have got now smart meter for electricity, for gas or water and everything. It is totally integrated. Your costs have also come down, and again, you're saving money not only on electricity use, on the gas use, on the water supply use, and as a whole, the country is being benefited. So there is no end to improvement. Improvement to what level is important for, in my view, for countries in SAARC belonging. We have got many problems. Economy is a factor, population is a factor in some countries, then technology is a factor, but through SAARC we are having exchange of all these ideas, because especially electricity in some places it may be surplus, in other places it is deficit. So if you have for smart technology, smart cities, you need to have continuous electricity supply. If Europe and Africa, they can go for electricity supply from one country to another, why can't we also do it? When we do this thing, then we can have smart environment in true sense. Your everything is smart, that's fine, but it has to be sustainable also. Unless it is sustainable, and it is of no use. So for that, you need to have a very reliable infrastructure. Not only reliable, it has to be financially viable also, because money is above everything. Government cannot give subsidy for long time. Whatever technology you are using for smart city or smart life, smart home, it has to be sustainable and it has to meet the cost. For example, driverless car are going to be very popular. It's already popular in Europe and America, and by 2030 there won't be any driver used car in Europe and America. Or the way you can say that driving profession will be obsolete in those countries. So you have to plan accordingly that for country like Bangladesh or in SAARC countries where driving is a very good, important profession, a lot of people are involved in it. So what alternate will come up there? Our fossil fuel based cars, they need a lot of mechanism. They are very inefficient. But when we have electric cars, it will have more durability because they have got very less moving parts. So employment in one side will be curtailed, and in employment generation, other side has to be balanced. The environment is an issue. Say about the smart city, the best thing is that with the full implementation of 5G, your use of computer timing, your use of to download data will be much less. As a result, you will have very less carbon emission compared to what we are doing it today. And unless and until you save your environment, you don't know what is going to the effect of greenhouse. Like you saw in my earlier video that 70% of the people will stay in only 2% land because greenhouse gas, whether you deny it or not, the way we are increasing our carbon consumption, it is going to eat up much of our land. The government and citizen machinery both must have positive approach for smart cities and sustainable smart cities. No bureaucracy should be there. Well, of course, with openness of your communication system, the bureaucracy goes. But above all, you should be, the more your education level, the more people are going to accept it. Like say Sri Lanka, their education level is almost 100%. So it is very easy to adopt smart technologies there. And other countries are also coming up. So you have to, mindset is to be there, and again, education level is to be improved there. So for sustainable smart city, as we found in sustainable development goal also, you have to consider ethical values. It is very important that ethics should prevail above everything. If you're concerned about your ethics, if your daily lives based on ethics, then you'll be concerned, oh, I need to save electricity, I need to save water, I need to put the reusable plastic material in the proper place so that it is used again. So because the problem which we are facing nowadays, that because of our less concern, the pollution is more and other things are more. So I will say, then I will say that you have got 3R, you follow reduce, reuse, and recycle. I will say again, reduce, reuse, and recycle. This is going to minimize your waste and your energy consumption also. And thereby you have a better or more efficient, sustainable city. This is my team, and that's also all from me. Thank you very much.
Thank you very much, Mr. Shah Zulfikar. It was indeed a very informative and very knowledgeable video. And of course, our experts from the municipalities would have learned a lot from this. There is an instant question regarding because we use a lot of terms and there are a lot of I mean, understanding of these renewable and these sustainable and green these cities. So how I mean how we can differentiate this smart cities with green cities?
Yeah, smart, ultimately everything is going to be green. And for green city, you have, it means that your aim is towards zero energy. You have got zero energy buildings, that is what in a, on yearly basis, whatever your energy consuming, you are generating. Say when you have got use generate your surplus electricity, you through your net metering you are giving to the grid, and when you are generating less at night time you are having electricity from the grid. So in fact there is a very famous thing that net energy zero energy buildings, zero energy cities, they are going to come up, but these are very costly and it will take time. So first phase is that you be smart, that your time is less wasted and your energy is wastage is also less. The more you that the more you go towards more efficiency, you are going towards more green. I think that answers the question. And I can also add
Thank you.
that
Yeah, please carry on.
they are green is there, that certification also is there. There the international certification say if you have got a green industry, your some taxes are away from you. There are many countries they impose that if, unless your industry is green or they maintain this standard, we are not going to take your products. So this is because of the greenhouse. This is all because of the global warming and our aim to go for at least 1.5 degrees centigrade less than what we are having today. These green technology and green issues are imposed.
Clear. It's very clear and very well explained. Thank you very much. There is another question from, please. Okay. There is another question that what would be the cost of transition to smart city?
Idea.
Some idea, some estimation, and what steps are involved in transition to smart city?
The best thing is that you pick up the places which are very which are thinly populated and education level is more, and you have a pilot project. You see, we are going towards smartness. It is there's no hard and fast definition of smart city. That's why I use the word you be more efficient. You increase efficiency in your transportation system, you have got wider road, you have got better metro system, your wastage time of your for aircraft, your flight delays, they are less. Say even countries like airport like Bangkok, though they are adopting smart technology, but because of the so much traffic is there that at times you have to wait for an hour to land or to take off. So it is that what is the need of the people and how you are going to accommodate it. The global concern is that with the increase of economy, improvement of economy, human demands, luxury thing, other things are rapidly increasing. So electricity demand is increasing at a geometric rate. And you have to overcome these things. Say a power plant takes around 5 years, but within 5 years, what you have planned, say you have planned go for 20% increase of power plant, you find that within 5 years, let's say demand has gone up by 50 years. So you use of your judgment to what people will need in after 5 years. On that basis, you go for smart technology. First of all, you go for smart homes, smart office. Government can do it very well that, okay, first of all, I'm going to make my all offices smart office, no wastage of electricity, no wastage of water, no wastage in file movement. You go for e-governance, e-filing, make your office paperless, but it will take time because for everything it based on connectivity. And it is of course it's expensive, but long time benefit is more. Initially, you might have to invest a lot of good amount of chunk on it, money on it, but say within 5 or 10 years, you will find that your savings is much more than that. But I don't have any It has to depend, it varies from case to case. You have to analyze the costing for that. But for your small municipality, if you got good industries, you have got good income, you can go for that. But most of the municipalities in our region, they have to generate their own income. So what you can do that you have a loan with 20 years or 25 years payback, and within that period, you can, whatever savings you make through different means, you can pay back the money. Can you hear me? Yeah.
Yes, we can hear me. Wanted to share that people are taking a lot of interest in your presentation. So there is another question that which are the example in the world to look upon for learning from them for transition to smart city. I mean, what good examples are, what international examples are there?
If we look around Asia, Singapore is an excellent smart city. Then Seoul is another fantastic city. You go to China, you will find a lot of smart cities are there. India, in our among SAARC countries, India is doing very good because our the culture and other things are similar. In Pakistan, also small cities, they are also coming up and going towards smart city. It depends on your economy. You want to go up to what level. New York is very one of the best, smartest cities in the world. The, the road which they constructed 50 years ago, they planned that what will be our traffic after 50 or 100 years, and they had the foundation to have the road at one after another. That's a very good example. So it depends on the your economic condition. You are going to be smart up to what level. But for Asian countries, I think Singapore is a very good example. For small one and for large places, you can go. China is a good example.
Thank you very much. I will take one last question, which is by Mr. Sohrawardi Khan. It is that what are the main barriers to creating sustainable cities? Do you think our region has financial capacity to overcome those barriers?
So thank you very much for this question. It's a very interesting question. Main barrier, your education level. The people have to be motivated. The government is to be motivated. The machinery, it can be municipality, it can be government at national level. They have to be motivated with the aim that we are going to make that city or those municipality fully smart. And with the involvement of the people, if the people are motivated, it is not that difficult. Economy is a factor because first of all, you go for smart, as I said earlier, you go for smart home system, you go for electrical vehicle system, but you have to be economically strong enough that when you go for solar renewable energy, initial cost is more, but ultimate cost is less. So they are getting funds from developing partners is no problem for smart cities, and it can be easily done. But population is to be a factor, which in Bangladesh, say in Dhaka capital city, it will take time. But government is working. They are developing one other means to be smart enough. So this the video conference which we are doing, this is also part of smart technology. So 10 years ago, we all used to be assembled in one place, spending a lot of money for traveling, hotel and other things. And you are, again, time was also a factor, a lot of hassle was there. But now you are sharing this knowledge and everything through these webinars. This is also a very good thing for smart. We are having video conferences. You thereby your traveling is reduced, your time is saved. So in fact, we are going towards smart technology and there is no end to it.
Well, thank you very much, Mr. Shah Zulfikar Haider. We indeed enjoyed your detailed presentation and also your good explanation of your questions. So, thank you very much for your time and your expertise. Thank you very much. So, ladies and gentlemen, so please.
Thank you very much for giving me the opportunity. and this I will request SAARC that you have more and more this sort of webinars. Sitting in our place, we can exchange view, and these are very helpful for development of the SAARC as a whole. Thank you, sir.
Very good. Thank you very much. Thank you very much. Noted. So,
Silent kar do.
ladies and gentlemen, we move to our next session, which is obviously last but not least. Our next presenter is Mr. Bruno Lafitte. Bruno is expert in lighting and energy efficiency. He's working as an international expert for United for Efficiency and UNEP initiative. For United Nations, his activities cover several countries in Africa for city lighting, domestic lighting, and tertiary sector. He is also expert in lighting for 10 years at the French Energy and Management Agency in France for domestic, tertiary, and public lighting. He is producing advices and decision tools for street lighting in cities and acting as a technical assistant for the Kampala's capital city in Uganda. So over to you, Mr. Bruno.
Well, I hope you can see my screen right now. Thank you very much for this opportunity. And the last, not the least, hopefully. I hope you will enjoy street lighting after this short presentation. This is an overview, but some potential on street lighting for saving energy, but also street lighting for sure is one of the best vector for smart cities. Why? Because you have street lighting everywhere in your city, and you have the network. You can have the electricity network, other the solar panel, so you have electricity. So it's a wonderful tool for smart city, and people are used to use it for making the city very smart. Can you see my slides?
Yes, Bruno, go ahead.
Yeah. Okay. So first we will talk about benefits of lighting, lighting by itself, and warning. Then we have a short presentation of different technologies, light sources, luminescence control, off-grid street lighting, because I think this is something that we have to consider, and this is by itself a smart device. And then we will talk about a comprehensive approach of street lighting. So first, generalities, benefits, and warnings. So benefits are safety, safety for the traffic, but also safety for gender issue, for women especially. Second benefit is development. Of course, if you put public lighting in a place, then you can extend the activity of the day during the night. So this is development. Nightlife, health, because street lighting and also lighting in general often comes in place of kerosene lamps. But you must be aware of urban spread because, well, I was in Nigeria, for an example, in Nigeria, in Nujda, they have a very good street lighting indeed, but downtown, and they did build some houses 1 kilometer away from downtown, and they just have to put a cable from the center to downtown, and in 1 kilometer you can imagine people were taking the current, taking the wire, stealing the wire, and so on. So the street lighting is a part of development of city. You cannot think about street lighting without knowing what the city will become in next future. One other thing to think about is light pollution. When you put lighting, of course, you can have light pollution, especially in modern city. You know this yellow. Let's say yellow dark on the dark city, preventing from looking at stars. This is an effect, but also it has a strong effect on animals and even on human beings. Another stuff is about cost. Often you think about street lighting in terms of energy consumption, the investment and energy consumption, that's all. But you have to anticipate cost of maintenance. It costs quite a lot, and even replacing luminaires after it fades. So this is a broad picture of street lighting. We see right from now this is a part of urban development. Street lighting is a part of urban development, and you cannot think about smart city urban development by itself without street lighting, of course. So next I will talk about light sources that we use for street lighting, because if we just come back a little bit, you see here on the left, top left, you see white light. This is street lighting, but on light pollution you see a yellowish cloud over the city. So this is more sodium. You have different colors of light. So light sources. First, the one important parameter, I won't talk too much about equations and that stuff. I will just show you some important parameters for efficacy, for the quality of light. So one important parameter is luminous flux. Luminous flux is the flow of photons. The total flux is the quantity of light produced by a light source. Okay, you can measure it using an integrating sphere. Here you see it's quite big actually. So you are able to measure all light emitted by sources in all directions. This is an important parameter. Well, a lumen is the luminous flux of light produced by a light source of intensity 1 candela over a solid angle of 1 steradian. 1 candela, 1 steradian is a direction, a solid angle. Like on the picture, 1 candela was the light produced by a candle at, I don't remember, 25 meters from the observer. This was the original definition of 1 candela. Now we use more solid physics definition. So next, the illumination, very important for street lighting, because often we talk about illumination on the pavement. This is normative most of the time. This is measured in lux. This 1 lux between the flux of 1 lumen arriving on 1 square meter. So the quantity of light on a surface per square meter. This is lux. Okay, so this is quite easy to measure compared to flux. Lux, you measure it with a lux meter. That's why most of the time we talk about quantity of light on the pavement in terms of flux. So for an example, if you want to light a typical road, you have to put 15 lux, let's say. You don't talk about lumen. Sorry. So next slide. And after I think we nearly finished with physics, so it's quite easy. The color temperature. The color temperature is the color of the light, let's say. So we won't go into details to talk about how we found it. This is a black body curve. black body is emitting one particular wavelength, maximum wavelength, depending only on the temperature. Well, whatever. So here on the right, you can see an iron. When you eat at the beginning, it's red. You see here at 1,500 kelvins, it's red, and when you heat up, it becomes more and more white. So this is the color temperature of the light. We talk about color temperature typically for white light, mostly for white light, but it goes from let's say red to blue or white blue light, and this is how color looks like. So you have all kind of color temperature for different light sources. When it's a red or blue light source, you cannot talk about honestly about color temperature, but usually for light that are used for lighting humans or lighting the street or indoor, we can talk about color temperature. So we see example later. The color rendering index now, this is also the last but not the least parameter. This is the ability of light source to keep the real color of object. It means the color you will see during the day with sunlight. So it's from 0 to 100. 0 you cannot see any color. 100 you can distinguish all colors. So here you can see a light source with a color rendering index of 100. So you can distinguish very well the different fruits. And here you can see different color temperature. Of course, you cannot distinguish between different fruits, especially on the top left. Well, this is color temperature. So your ability to distinguish color is depending on the color rendering index of light source, and this can be quite important when you have road signs with colors for people on the street, for cars, whatever. If you are not able to distinguish color, it can be dangerous sometimes. Even if you imagine a smart city with color signs, different color signs, it's an important parameter to consider. Next slide. Next slide. Here you can see the different, I will talk about different light sources that you can use for street lighting. This is a low pressure sodium. I don't know if it's very used in Asia. I think a little bit more, actually, as far as I know, a little bit more than in Europe. In Europe, we don't use it quite often. This is very efficient light source. You see the power from 18 to 180 watts, but very efficient. It can go to 200 lumen per watt, which is lumen, the quantity of light produced, the flex, per watt, the electricity, the power that is consumed. So lumen per watt is the ability of your source to convert electricity into light. So the efficacy of your source, basically. So the energy efficiency is about 40%. You could say it's not too much, but actually it's a lot. It's a lot. Lifetime until 18,000 hours. Well, for the best one. You cannot talk too much about color rendering index because it's really yellow, deep yellow. Deep yellow. Usually, you speak about color temperature of about 1,800 Kelvin, and usually we use it for tunnels or to light some spaces where you don't need too much to see to distinguish the color. It's not very, people usually don't very like this kind of light, but it's very efficient and it can last long. Okay, so this is a discharge lamp. Keep it in mind. Next one, high pressure sodium. So it's still using sodium. So you can see some picture here. Well, it's not a very nice picture, but it's yellow, still yellow because it's using sodium. We were talking about low pressure sodium, now high pressure sodium. So it's more white yellow. The color is better. You can see high pressure sodium everywhere. When it's yellow in a city, usually it's high pressure sodium because you can see all kind of power, quite good efficacy. It can reach 131 lumen per watt. The color rendering index is not so good, but it's you can talk about it. The color temperature is quite low, 2150 Kelvin, because it's yellow. And lifetime is quite good. So this is a very common light, and this is quite efficient. But we see we have better now, and it's also good for smart city. So high pressure sodium. Here you can see the spectrum of the emission spectrum of high pressure sodium. You can see the color, it's more in the yellow region because of the sodium typical emission in the center, about nearly 595 nanometers. Okay, so that's why it's yellow. Next one, ceramic metal light lamps. So you can on the right you can see the picture. This is very small. This is where light is emitted in a very small area compared to others, but it's a very powerful light, quite efficient, with a very good color rendering index. You can see there are 95 color rendering index, so you can distinguish all colors. Color temperature from 3000 to 4500 Kelvins. So I forgot to tell you, when the color temperature is low, it's more red, yellow, like for sodium lamps. And when it's high, it's more white, blue. Okay, so you can have all kind of colors and a quite good lifetime. So this is a quite good light, but depending on the flex, we'll see later. Next one is high pressure mercury lamps. I don't know about your country, but now it depends on the country, of course. But now in Europe, it's banned. You're not allowed to put on the market high pressure mercury lamps. Why? Because it's not efficient. You can see the maximum is 50 lumen per watt compared to 130 something for a high pressure sodium lamp. So it's less than half of the efficacy of sodium lamps. It's not so good. The color rendering index, well, not that bad, but it's not efficient, and it contains a lot of mercury. Yeah, we will see it later. All lamps that we were talking about are discharge lamps and contain mercury. You cannot imagine a discharge lamps commonly used, not in laboratory of course, but commonly used without mercury. And mercury is harmful. You did sign, I checked for some of your countries, you did sign some protocols to get rid of mercury and to recycle it. So this is an important parameter to consider. You have mixed lamp. I guess you don't use it. It's an old lamp. It's not efficient at all, mixing between incandescent and high pressure mercury lamps. I don't want to talk too much about it, except if you have questions. You have induction lamps also. You can find a lot in your country, actually, in Asia. This is a lamp without electrode. You have an antenna in the center. You can see it on the picture, and then you create a magnetic field. So electrons are turning and emitting light. After that, I don't go into details. Quite efficient, a very good lifetime, 60,000 hours, so very good because you don't have electrode, but not that efficient actually. But a good competitor compared to LED, of course. LED is, we think, the future for all kind of lighting actually. Few years ago, I wouldn't have said that. A few years ago, I would have said, okay, LED are good for domestic lighting, indoor lighting, but not for high power, not for street lighting. Because we are not that efficient to dissipate the heat of LED and whatever. But now LED are ready for all kind of application, and we see that. So the power can range from 20 to 100 watts and even more actually. The efficacy is depending a lot on the luminaire, but it's common to find an efficacy higher than 100 lumen per watt. A good color rendering index, so 70 is the lowest. Actually, you can reach even 90. The color temperature, you can have all kind of color from red to blue, let's say. So you can choose your color, and the lifetime you can have from 20,000 to 100,000 hours. So this is a very interesting light source. When you compare it, this is a comparison of different light sources. So low pressure sodium, high pressure sodium metal lights. The first three are quite efficient, higher than 100 lumen per watt. You see the maximum efficacy. High pressure mercury mixed and induction are not that efficient, so you should forget it for energy point of view. And LED luminaires are quite efficient. So first you have from 2, 4, 6, 7 kind of light sources. You can eliminate 3. After, you have to consider the light by itself that is emitted. The low pressure sodium emit deep yellow. So it's most used for tunnel, industrial platforms, and so on. It's quite efficient, but for 32,000 lumens. Okay, if you have a lower need, it's not that efficient. The efficacy, the maximum efficacy is for a certain quantity of light. That's the issue. It means high pressure sodium. Okay, it's clear yellow. It's very efficient, 130 lumen per watt, but for 33,000 lumens. This is for roadway lighting. This is for higher than 8 meters. This is quite a lot, a high quantity of light. So it's good for a luminaire which is quite high, illuminating roadway, large area, but not for downtown when you have not so high luminaire, and for, let's say, it's typically used for downtown with 70 watts. But at 70 watts, it's not that efficient at all. You shouldn't use high pressure sodium. 33 lumens is high pressure sodium lamps with, let's say, 250 watts. That is quite good. But 70 watts, no, please don't use that. You have other kind of light sources like this is metal lights. This is ceramic metal lights lamps. Here for 10,000 lumens, you have an efficacy of 115 lumen per watts. This is quite good. And here you can see a red sun and a blue sun. It means that you can have all kind of color. So this light is quite good for town center, commercial areas, and so on. Not for roadway lighting. So it depends on your application. But LED is quite efficient. It's less, let's say, the same efficacy of high pressure sodium for higher flux, but it's the same efficacy for every kind of flux LED. This is a big advantage compared to the light source, and it lasts long. High pressure sodium, for example, lifetime is about 25,000 hours. So for typical use of street lighting, it's a little bit more than 6 years. But with LED, you can have a lifetime of 100,000 hours, so more than 20 years. This is quite efficient and it lasts long, so you don't have to replace it every 5 to 6 years. And you can have all kind of color with LED. So one other important parameter to take into account is mercury. We were talking about it. Maybe you've heard about the Minamata protocol, the Bâle Convention, and so on, to get rid of mercury, to limit the amount of mercury and to recycle it, because it's very harmful for people, for brain, for babies, for children, and it's a very harmful element, mercury, high toxic element, heavy element. In high pressure sodium, you can find 25 milligrams of mercury. Of course, it's less than, let's say, mercury high pressure lamps, 60 milligrams of mercury, but you still have mercury in high pressure sodium. So this is a discharge lamp. Even if in ceramic metal light lamps, I didn't put any number because it's depending a lot of the kind of light, but you have about 20 milligrams of mercury also. So one thing in favor of LED don't have mercury at all. So you must recycle it. It means used LED are waste of electronic and electrical equipment. So you must recycle it, of course, like every kind of electronic equipment, but it doesn't contain LED. So it's much more easy to recycle it, and you can recycle with all kind of electrical equipment. So now, I told you a few years before, I would have said, okay, you must consider high pressure sodium, ceramic metal light lamps, and so on. They are quite good. I would say still now, they are quite good, but you have to take into account the lifetime. Okay, it's cheaper. It's much more cheaper usually to change just the light inside the luminaire. Okay, instead of going for another complete luminaire, LED luminaire. So when you have to change your street lighting completely, you go for LED lighting for sure. When you have just to maintain your street lighting, okay, it's cheaper to change just a light source, to change high pressure lamps or ceramic metal light lamps in your existing luminaire, but you should consider the lifetime cost of your device, and you must do a carefully calculation taking into account maintenance. Okay, so we are talking, yeah, this slide is about the Dark Sky Association. We were talking about light pollution. You can see a slide from the Dark Sky Association fighting light pollution, mostly for stars, for looking at stars. It was created by astronomers, but now they take into account the effect on animals and human beings also, and trees and so on. So you must to limit light pollution. Light pollution is light that is not used for I mean, you spread light everywhere. When you have a luminaire that emits light toward the sky is not used for lighting anybody except the stars, but the stars have their own light. So you don't need to light stars, you need to light the people, you need to light the city, and not the animals, not the field, not stars. So it's energy that you lose also. It's light pollution. It's harmful, but it's energy that you don't use for lighting everything, anything. So next slide, luminaires and control. Here another slide to explain you a little bit more. So you see Euler upward lumen output ratio. This is the percentage of lumen that is emitted above the luminaire, so lighting the stars. This is something that is lost. Energy is lost, and this is light pollution. So we don't want it. Useful light here is quite narrow compared to what is emitting a traditional luminaire. So one simple parameter to limit light pollution is to say, okay, we want a luminaire with upward lumen output ratio of 0%. Now we can do it. A few years ago, it was quite impossible because you tilt the luminaire to light all the street and so on. But now it's possible. So this is one advice. Please, when you buy a luminaire, whatever is made for, please buy Euler 0%. Think about this is smart lighting already, dimming and presence detector. Think about it. Dimming is when you reduce the quantity of light during the night, because you don't need a road is changing during night. I mean, for an example, in a commercial area at 7 o'clock, 7 p.m. for an example, you have a lot of people. And so you need a lot of light for security reason and because there are people. But at, let's say, midnight, you have nobody in that area. All shops are closed and you have nobody. So you need less light. Here it's at 11 p.m. you need less light. And once again, when shops are opening at 6 or 7, let's say, you need light again until the sun is shining. So this is dimming. You can take into account the needs of people, the needs of light on a particular street, which is changing during night with dimming. And with dimming, it's quite simple to dim a luminaire. You have a simple tool to do it. I don't have time to go into detail, but you can save let's say 23% in that example, that particular example. Now what you have also, this is quite new for street lighting, but it works quite well with smart detectors like presence detector. So you have for particular street lighting, you can have a dim light usually when nobody is there. So people are still going into the street because there's a little bit of light, and when people are engaged in that street, that particular street, the light is going up to 100%. So there's a detector, a presence detector that says somebody is going into the street. So I have to light at 100%, but if there's nobody, only 50%. So you cannot use it in every street because there is safety issue, of course. But you can use it in most of the street when you have only pedestrians. For an example, you can easily use it. My advice is don't make the lower level being 0%. Otherwise, nobody will come in the street anymore because there's no light. And when there's no light, there is danger. The perception of danger, let's say, or it can be a real danger. So nobody will go. But if you keep 20% or 50%, we have the experience. People will still go into the street, and then it detects people, and you have full light. So it's huge amount of saving that are possible. 42% of saving in average, and that is this is quite new that you can use it. You can use it because you use LED. So LED you can switch it on and off very quickly, and also because now you have good detectors. Few years ago, 1 or 2 years ago, detectors were not able to distinguish between human being, a cat, a rat, or whatever. So light was still at 100%. Now we have very good presence detector. You can even have a camera, a shape recognition, accident recognition, and whatever. It's quite crazy what you can do. And once again, you have street lighting everywhere. So depending on what you want to see, you just put a detector on your poles, and you see all what's happening in the city. So now I wanted to talk about off-grid lighting because off-grid street lighting. I think it's very useful, even if we talk about smart city and we are in big cities or whatever, but sorry, off-grid street lighting can be used everywhere now, even if you have the grid, because most of the time the grid is not in good shape, the electrical network, I mean, and you can have, for example, flooding or whatever, and you have to do work for the grid. It costs a lot to maintain a good grid, electrical grid, only for street lighting when it's used only for street lighting. Of course, when you use it for the purpose, okay, you use it. But most of the time in some cities, it's only used for street lighting. And if you have not a good grid, you must think about off-grid street lighting. Here you have, I won't go into detail, but you have a complete comprehensive guide which was produced by the International Solar Alliance, which is an international initiative. At the beginning, it was between France and India, but now a lot of countries did join. So you have the quality, how you should think about street lighting, off-grid street lighting project. How you should go for let's say financial setup, your design, implementation, how you should consult people and engage different stakeholders and engage community and so on. The preliminary design that is used for this particular guide, I made it actually. I was technical advisor for this guide, so I made this table, which is used for off-grid street lighting, but can be used also for on-grid street lighting. So I divide three kind of roads. On other paper, I will give you some references if you want, but on other papers, I put 5 or even 10 kind of roads. But for this guide, 3 kind of roads: main road, road passing through villages, local roads, or public spaces. And for that particular type of roads, I gave an indication of the luminance level that is good usually for people. So 15 to 20 for main roads, 10 to 15 for local roads, and 5 to 10 to public places. So just to remember, illuminance is quite easy to measure, and this is something that is used. Okay, just here you can see the illuminance. It's the quantity of light on a surface, and quite easy to measure with a lux meter. Okay, so this is normally a normative. You can see a lot of norms that are talking in the illuminance level that you have to put on places. Uniformity is you can have between poles a dark spot in the middle, and it's measured by uniformity of light. Uniformity is the minimum illuminance divided by the average illuminance between those two poles, and it could be high. It must be higher. Sorry, I didn't put the sign higher than 0.4 to have a good illumination of your street. Duration of light at full power. This is normally what is the advice before dimming or presence detector. Minimum level of light when dimming. You can do dimming everywhere, but you have to maintain a minimum level of light, especially for main roads. It's important to maintain a minimum level. Light control for main roads, you control all luminaires together. You can have a remote control um, for the light, and you control all luminaires on the same road. So people are not disturbed by different kind of light on this road, a different level of light depending on luminaire. For local roads inside villages or inside the town, you can use, of course, presence detector or extension. We were talking about it. For public places, you can use presence detector. Not extension. I wouldn't advise it, but it depends on you. The height of luminaire, of course, is quite different, and for main roads, you can have high pressure sodium with high power, 8 meters, and public places, you can have a lower height of luminaire. The height is very important because when you have a lower height of luminaire, you can lower the power that you put inside your luminaire. Of course, because when you are near the surface, you need less power to have the same amount of light on your surface. The color temperature, you can use what you want. I would advise to be lower than 5,000 Kelvin, let's say, to not to have this blue light pollution. Because when you go for higher color temperature, let's say higher than 5,000 Kelvin, you have a white but big component of blue in your white light. Okay, when you have lower color temperature, it's red. Higher color temperature, it's blue. So it can be harmful for people and animals, this blue light. Quality criteria of your system, because solar lighting system is quite complex system. You have a photovoltaic panel, you have a battery, you have a detector, and you have your light by itself, your luminaire by itself. So we designed with some people and some experience quite easy criteria to check. First one is power of modules in your photovoltaic module in watt peak divided by the power of the luminaire must be higher than, let's say, 2 or 3. This is a ratio that you can easily check. The power of your solar panel divided by the power of your light source must be higher than 3, let's say. Second one, the power of your solar panel divided by your daily reference consumption. I mean, if you light, for an example, 5 hours with 20 watts, it's 5 multiplied by 20, 100 watt hour. Okay, so your module power divided by your reference consumption must be higher than 0.5, 0.6. Also for solar lighting, take care of batteries, battery technology. There is 3 kind of batteries that I used. Lithium ion, that is very common for cell phones or whatever. Nickel and NIMH. I don't remember how you spell it in English, but how you call it in English. But this is nickel batteries, let's say, and lead batteries. Of course, lead is very attractive because lead batteries are quite cheap compared to other kind of batteries. But if you consider the total cost of ownership, you can use only 10%, let's say, of a lead batteries. So you have to oversize it because if it's discharge higher, lower lower than 20% of the capacity. I mean, you use 20% of the capacity of the lead battery. It lasts only, let's say, 2,000 cycles, which is very few, very few. It means 3 years basically, because you have how many nights during a year? You have 365 nights during a year. It won't change. It won't change. So 2,000 cycles is only 3 years. 3 times 360 is 2,000. So it cannot be used for street lighting for sure. And lead is also a toxic element, so it cannot be used. The other 2 technology, nickel batteries and lithium batteries, are quite efficient. Both are quite efficient. Lithium tend to be a little bit more efficient than nickel batteries. So next slide, sorry. Here I will show you a more design tool for solar street lighting that you can use. So I took some assumption. I don't want to go into details, but here are design tools. So this is for particular irradiation in water per square meter per day. And it's something that we can discuss about it later, but depending on the area you want to light, the power and so on, you have the surface of the solar panel, the capacity of the battery you should put, and so on. So this is a complete design tool. A comprehensive approach, last slide. For street lighting, you have to do a pre-diagnostic to assess for your need, your possible saving. Then you have you decide does it worth to go for a real diagnostic with engineers and so on, because it can cost a lot, but most of the time it worth it. So you go for an operational and technical assessment, planning budget. Very important. Use the new tools of today. The presenter before me was talking about it. You use your computer basically, and your geographical information system, so you can remotely control of kind of light in your city. Financing is important with energy performance contract, which are quite efficient contract, works, and sustainability. This is the last point, but think about maintenance and anticipate your budget for maintenance when you have to change the light, or even when you have to clean your luminaire. So thank you. it was very quick overview of street lighting. I didn't even talk about smart cities because street lighting is smart cities. You cannot think about smart cities without a good street lighting. And as I said, you have your network, your electricity network everywhere where you have street lighting. So this is uh, for smart cities everywhere. You can see detectors on the poles for street lighting. You can see a remote control of those detectors, and all is using street lighting. So by itself, it's smart cities.
Thank you very much, Bruno. I wish I could listening to you. It was indeed a very informative and detailed presentation, not only covering technical aspects, but you cover international experience very nicely. I am sure representatives from other member states would have definitely learned a lot from your rich knowledge and international experience on efficient lighting. So people have taken a lot of interest in your session and a lot of questions are awaited. I will try to cover as much as possible. Now, my first question is from our friend from Maldives, Mr. Essen, whom is Maldivians are very concerned about environment. So we all are. He's asking that about any latest recycling disposal techniques of LED being followed in European Union, such as France or other advanced world.
Okay, and thanks a lot for that question. Actually, it's a very important question. Usually, we have in Europe what we call the responsibility extended to producer. So the producer of LED lighting has to think about recycling the products that they put on the market. This is a law, and for that, what they're doing usually they don't collect it and recycle it by themselves. They work together, the different manufacturer, and they create what they call a company for recycling and CRSO. They call it that way, and it's a company that is dedicated to collect the light and to recycle it. So they create it, they fund it by themselves because they have to.
Okay, thank you. Another friend from Pakistan, he's asking that what lighting options you will propose to municipalities official in terms of all in one, such as efficiency, life, and cost, because they, apart from technical, most of the participants are from a managerial background and they are more concerned to these main terms, not interested in much technical details. So they're interested what uh, specific light you will propose in the latest scenario for municipalities in SAARC region.
Well, yeah, I'm sorry. I had to talk a little bit about techniques, but it was very light compared to what we can talk about. But this is a good question. I did present a lot of different options, but my conclusion would be if you have the money and if you want to renew your street lighting, go for LED for sure. If you really don't have the money and you don't want to change all luminaires, you can use high pressure sodium for roadway lighting or ceramic metal lights lamps for public places, but that's not that efficient in the long term. This is most cost effective. The total cost of ownership is much more better for LED because it lasts long, it's quite efficient, and you can use it everywhere.
Okay, thank you. Another connected question is that can we replace the lighting in existing infrastructure and the fixture we already having in our street lights? I mean, we can change only lights inside the fixture?
Yes, for when you use discharge lamps, you can change only light. But when you use LED, this is a very important question. You have two kind of LED luminaires. LED with modules. This is equivalent to the lamps in high pressure and discharge lamps. LED with replaceable modules. So module is equivalent to a light. So you just have your LED luminaire. When it fades, you just have to replace the module. But most of the products sold today in the world are not replaceable modules because well, at the beginning it was replaceable, but most of LED luminaire use non-replaceable modules now. This is I don't really like it. If you can go for replaceable module, it's better. But LED modules are lasting 100,000 hours typically, so it's a lot. So even if it's non-replaceable module, you just change your luminaire when it's after 100,000 hours, and it makes sense.
Okay, thank you. Well, there is a general question, maybe at least I also have similar experience that particularly when it comes about LED lighting, we know and we have these scientific evidences. You also mentioned that they have a good lumens per watt. But still on ground, when we change these lights, we feel maybe it's psychological, maybe you can better explain that on ground we feel a difference in light if we compare sort of apple to apple comparison with CFLs or these fluorescent tube lights like T8 and T5. So then on ground we feel that with the same wattage we have different lighting, I mean lesser lighting for LED. Whether it could be psychological or it could be technical, or you may explain in better way. So that is the question, that why we feel difference of this lighting
Yeah,
compared with LED.
yeah, well, the answer is not that easy because it depends on situation, but it depends a lot on color temperature also. Usually, when people are saying for the same power, we don't have that much light with LED, it's because the color temperature is not the good one. At night, if you use a color temperature of let's say 3000 kelvins, like high pressure sodium, you won't see as well as you can see with the same color temperature during day. It means that for street lighting at night, you need a color temperature of about 5,000 kelvins is quite good. And here with not so much watt, you can see very well with more blue light, let's say. If you use a yellow light, a yellowfish light, you need a lot of watts to have the same feeling of seeing objects. So it's not an easy answer.
Okay. The last question we got is from Pakistan, because we have a lot of, I mean, street lighting, LED street lighting in place with replaced with the previous conventional lighting. But normally we saw flickering in these lights. I don't know whether it's in combination with solar. What the problem is non-technical, on non-technical basis. The question is that why this flickering occurs, whether it's I mean, over or under capacity, or it's technical problem, or it's quality problem.
Sorry, the line was not so good, so I couldn't. Your question, can you please
Okay,
repeat it?
okay. I'll repeat in simple words that normally with street lighting that are replaced with LEDs, we usually experience flickering in the night time, like
Yeah.
passerbys. Non-technical basis, I'm asking this question, that why this flickering occurs, whether it's quality issue or it's some
Yeah,
under or over capacity problem.
Yeah, this is a big issue actually, and this is something that we work on very. This is something that we consider in the new European regulation. This flickering with LED is quite often you can experience flickering with bad quality products. And we did put in place some parameters to measure and limit this flickering in the new European regulation that will come into force in 2020. So you can find it on the website of the European Commission, the SVM parameters used for limiting this flickering. But yes, you can experience this with bad
Much,
quality
Bruno.
products.
Right, right. Thank you very much. I believe you mentioned you have to travel somewhere,
Yeah,
and
yeah, yeah.
maybe it took a lot of your time.
Thanks a
So,
lot. Thanks a lot for this opportunity. Thanks for the audience for keeping on the line. It was a long webinar for you. Thanks a lot. And here you have all my details, my email, phone, and so on. Please feel free to contact me.
surely, surely. Once again, thank you very much. So, ladies
Thanks.
and gentlemen, now we move to our conclusion session. If after listening to the experts, it can be easily assessed that this is such a vast topic and holds a huge potential that needs a lot of effort to work on. At this point of time, what I concluded based on the discussion and some of my own research, that there are two broader categories the municipalities have to focus upon to implement energy conservation and efficiency in their operations and jurisdictions. Firstly, municipalities should target their own operations and install energy efficient technologies and management interventions within municipal operations. Depending on the profile of the municipality, energy efficiency opportunities are easiest to realize in lighting interventions, particularly street lights and traffic light retrofits. Other major areas could be hot water systems, variable speed drive motors for water systems, improved insulation and heat recovery, etc. To achieve these targets, some standard steps have been identified by various experts in different studies and also mentioned here by our first expert that what you have to need is that to start with an overall energy management plan outlining aims, objectives, and targets for energy efficient interventions. Then you have to conduct an infrastructure and building assessment to determine which infrastructure has high electricity consumption. Then shortlist particular infrastructure for further investigations. Conduct an energy audit on the infrastructure to determine energy efficiency potential. This could include installing a metering system as well. Develop a business plan for assessing payback periods and potential technologies and technology interventions or management approaches. Conduct a procurement process, monitor energy savings, and ensure that adequate stock of the new technologies in stores for maintenance purposes. The second broad area of opportunities for energy efficiency could be where the municipality plays a facilitator role in driving energy efficiency, both within municipal operations and the broader community. This could be through a communication focus on energy efficient interventions, promotion of energy efficiency technology retrofits, such as incandescent light bulb replacement program, or it could be a behavior change program, such as competitions and games and mass awareness for the mass and public awareness. To apply this municipal energy strategy should be developed that outlines where and how key energy saving areas will be achieved in different sectors of the economy. The strategy should also highlight how, when, and by who these targets will be achieved. Once the strategy is in place and internal coordinating energy committee should be established to track the implementation of the strategy. So, ladies and gentlemen, with this, I may like to conclude our webinar with an announcement that SEC has planned a couple of webinars on the subject. This was the first webinar of the series. Next webinar will be organized in August 2019. I request you all to join this webinar with us. Thank you everyone for attending today's webinar.
Suggestion.
And I will also request that we have recently started this activity of conducting these webinars. So we would request you that if any suggestion from improvement from your side would be welcomed, and we will look into it. Now, thank you everyone for attending today's webinar. We had listened to some excellent presentations delivered by our distinguished presenters from member states and other regions around the globe. All presentations will be available on SAARC Energy Center's websites www.saarcenergy.org very shortly. We would love to hear from you any suggestions and comments for further improvement, plus any suggested topics of your interest on which you want us to arrange future webinars. We would gladly do that. With this, I'm signing out. Thank you again for joining us today and looking forward to see you next time. Bye.